Hope everyone had a good spring break. But now we're in the home stretch. These final 8 weeks are just going to zip on by, especially if you get behind. When you get behind, it seems to go faster, right? It's like, oh, I don't have enough time to catch up. So you don't want to get way behind. You want to stay on top of things. Uh, if you're behind assignments, get caught up as quick as you can. So that way, the end of the school year does not come as a huge surprise and panic. Let's see. We've got this week is what's due is this activity that I'm going to go over and the practice exam because we're at the end of the unit with this. This activity that we're doing today just kind of uses all the stuff we've learned in the 8th unit in module 8 and puts it all together in a 50-point activity. 50 point. Most of others have been worth 20. Everything else in this module 8 has been worth 20 points. This is worth 50 points. So you want to make sure and don't skip this and put in some good effort on it because it's worth like 2.5 of the other assignments. But let me talk about what all this week you got. Like I said, the practice test and this module activity here, which is called Whale World. Right, so we're going to go to Whale World, like a virtual trip to Whale World today, this week. And so Whale World has, well, that's hard to say today. I don't know if that's not working. Whale World has recruited you to help. They're going to build a marine-inspired park in your city, right? So, yay, we're going to big whale park here. I don't think whales fit well in the area. We're not exactly near any oceans, but they're designing a theater where a killer whale show will take place. So either it's a whale show that's just killer, or it's a show with killer whales. But either way, it's a killer whale show this week. So let me put that up on the screen as we talk about what this week's assignment is going to entail. That's kind of a whale joke, but no. There we go. Should be coming up on your screen there. All right, so let me talk about what this week's assignment is. So at the end of at 806 activity there, it has choose option 1 or option 2. We're doing option 1. Option 2 is where you work with another person. And since we're doing this virtually on our own in our own houses, we're doing option 1. So this is the work independent option. So talks about this theme park, building this marine inspired park, right? A killer whale show, and they need your help. So they've already got the design under construction, and it's going to house the whales. And here's what it looks like right here. We've got this main show tank right here. That's where, so the audience will be seated around this. So there's the tank where the main show is going to happen. There's a platform where the employees can walk and give commands to the whales who will do all the tricks. And then back here's the 2 holding tanks, and the walkway where the trainer can go back near the holding tanks. So the main tank has a radius of 70 feet. So here's what we do. Step 1, calculations. Let me look on page 2, the bottom. What to submit for this assignment. This is what you're going to do. The calculations and work for step 1, which we're about to go over, and then your answers to the reflection questions for step 2. So let's look at step 1, the calculations. So what we have is the main tank has a radius of 70 feet. So this is supposedly half a circle. And it's drawn to look like a little bit more than half a circle, but they're telling us that this is a quarter sphere sized tank. So this is intended to be a semicircle right here with a radius of 70 feet. All right. And they say it's a quarter sphere, which means if you had an entire ball and you cut the top off of it right through the middle of the ball, that gives you a bowl, right? The bottom half of it is a bowl. And that is what the tank is going to be shaped like. But they're cutting that in half again. So it's just half of the bottom of the ball, of the sphere, of the globe. So it's going to be a quarter of an entire sphere because it's half of a half, right? So that is the shape of this big tank where the show is going to take place at. So what they want to know is, what is the volume? How much water will that hold? They need to account for that. They need to know exactly how much water they're going to need so they can get in their figures and calculations, all that stuff. So the volume of the quarter sphere size tank. So going back to the notes, we make notes Here's the notes I had made for this unit, right, that I would use on the test at the end. I see the volume of a sphere is 4/3 pi radius cubed. So that's the calculation, the main show calculations. I know the volume would be 4/3 times pi times the radius cubed, and I have the radius, but it's just a quarter of it. So all of that I would have to take times 1/4, right? Or just divide by 4, either thing. Multiplying by 1/4, dividing by 4, same thing. But that's how I would calculate the volume of this quarter sphere size tank. It says round it to the nearest whole number. They don't care if it's a partial cubic foot. They just want to know to the nearest whole number. And it says use words, explain your answer, show all your work, show your calculations. Because that way, if you mess up something, instead of just giving me an answer that's wrong, that I have to say, well, I can't give you any credit for an answer that's wrong. You show your work, and I see you made a little small error somewhere, you'll still go almost all the points because it was just one small error, right? So you want to do that. All right, so after we do this, then we have the holding tank calculation. So we have 2 holding tanks. And it says they're congruent in size, so that's important to know. So they're exactly the same. They're congruent in size. And both are in the shape of a cylinder that's been cut in half vertically. So picture a can. You have a can, and it's cut in half virtually, right? So up and down, right through the center of the top of the can. It's been cut in half, and then it's been laid on the side. The bottom of the tank is a curved surface. See, it's cut in half vertically, and then they lay it down. So here's half the cylinder, and here's half the cylinder. So if you think about that cut in half, that means combined, it's one cylinder. It's just one cylinder combined. Half of the cylinders over here is holding tank number 1, half the cylinders over here, and it's been sliced in half this way. If the can was standing up, it'd be up and down. You lay the can down, they sliced it from the top of the can to the bottom of the can, which would be sideways as it's lying here on the table. So cut in half vertically. The bottom of the tank is a curved surface, right? The bottom of the tank, because that's the side of the can, the side of the cylinder. It's a curved surface. What is the volume of both tanks if the radius of tank number 1, so this one, the radius, which would be, the end of it would be a semicircle down here, right? It's a semicircle. The radius is 15 feet. And then for tank number 2, it's 120 feet from here to here. That's the height. It says the height, but remember, it's a cylinder lying on its side. Just because it's lying on the side doesn't change what the base of the cylinder is. The base is still the ends, at the round ends of the cylinder. And the height is, in this case, as it lies down. But that's still the height of the cylinder. So it says the height of this one and the radius of this one. But the key thing is it says the congruent. So that means they're both a radius of 15 and a length of 120, right? Or height. So you got to explain using words, so working calculations, the holding tank calculation. So cylinder, the volume equals pi radius squared times the height. So you got choices there. You can say, okay, if I divide that by 2, that'll be 1 tank, and then I have to multiply it by 2 because I've got 2 of them. Or you can say, well, dividing it by 2 and multiply by 2 doesn't do anything. I'll just figure out what 1 cylinder is, and that is the volume of both tanks, because combined, they make 1 cylinder. So that is our holding tank calculations. The other calculation is the density, okay? So they said in step 1, you found the volume. Up here, we're going to figure out how big is the main show tank. How many hundreds of thousands of cubic feet, right? It's going to be a big number. It's going to be big enough to hold whales. If you end up with a number like 840, you're probably off, right? If you end up with like 4 million, it's not that big. I'll tell you, it's less than 1 million, but it's hundreds of thousands. So you found the volume in cubic feet of the main tank right there. And they say the maximum density of the killer whales per cubic foot is 0.00001142. Just a little bitty portion of a whale per cubic feet, because whales are going to take up a lot of cubic feet just for one whale, right? So this is the density. Density. They told us that's the density. So when we go back and look at our notes, density is mass divided by volume, right? So density equals mass divided by volume. They gave us the density. So this number is going to go right there. That number goes right there because that's the density. The volume, we found that number up here. So this number is going to go right there. And we have to solve that for M, which means we have to rearrange the equation. Right? We have to rearrange the equation. If we want to get M by itself, we need to multiply by volume. So multiply both sides by the volume. Those will cancel out. And volume times the density will give you the mass. And that will tell you how many whales they can have in the main tank at the same time. Right? Because if they have too many in there, it's going to be dangerous. The whales could injure each other. There could be lots of issues there. It could injure one of the employees on the stage if there's just not enough room for the whales. So they need to figure out the maximum amount of whales they can have in the show at any one time. All right. So the density calculation, that tells us the mass, and the mass is the number of whales. So does it tell you to round that? I would say you certainly have to round that. It doesn't say that. The maximum number allowed at any one time. You would round that, right? Because if the answer is like 6.7 whales, we're not going to put 0.7 of a whale in there. It's going to freak out the people watching the show. Oh, what's that big partial whale over there, right? So we're not doing that. And now the question is, if you can fit 6.7 whales in there, which is not the answer, by the way, I didn't calculate anything. I just made this up, 6.7. You don't round up because that means 7 whales is bigger than the calculated density, which means the density is going to be larger than that for 7 if the answer was 6.7. So you'd always round down. The maximum number would be 6 whales. We could have part of another whale and still meet our density. But again, we're not putting part of a whale in the show. So you always round down and just cut off the decimal and say, if it's 6.99, 6 whales. That's all you get. Can't put 7. All right. So that is the calculation portion of this. So that would be what to submit there. The other part is the answers to the reflection question. So here's our reflection questions. Okay, so show any steps providing the evidence needed. That would be like a calculation you need to back up what you're saying. So it says the theme park company is building a scale model. Okay, so we're going to build a model of it. You know, like people build little model cars and model airplanes. And, you know, you might have some at your house, even little scale models of the Whale Stadium's main show tank. So they're building that quarter sphere. And they're going to do that for an investor's presentation. So they can go to someone that they're looking for raising money to build this. And they say, look, here's what it's going to look like. Here's what our show tank is going to look like. And they can take a little model and show them. They can put water, maybe some little plastic whales if they wanted, however they want to present that. But they're going to build that in each dimension. Oh, that's a key thing. Each dimension will be 6 times smaller. Okay. Which means the radius will be 6 times smaller in the mock-up for the presentation room. So how many times smaller than that is the actual volume? If the big tank held 600,000 gallons, and this is going to be 6 times smaller, it's not going to hold 100,000 gallons because volume is a cubic calculation. Volume is a cubic calculation, right? We're going to take that radius and we're going to cube it times 3. I mean, times itself 3 times. Radius times radius times radius. So if the radius is 6 times smaller and we're going to take it to the 3rd power, that means it's 6 times times 6 times times 6 times smaller. 6 times 6 times 6. It's not just 6 times smaller. So how many times smaller is the mock-up than the actual tank? So then, once we know that, answer the following question. The volume of the actual tank is what percentage of the mock-up of the small mock-up model tank? It's going to be bigger, right? If it was 100%, that means it'd be the same size. If the actual tank is 200% of the mock-up, that means it holds twice as much water. Okay. It's going to be a big, big number here because the actual tank will be many, many times bigger than a smaller tank. Let's say that up here we found out that the mock-up is 110 times smaller. I just made that up. So it's 110 times smaller, right? We said our answer is 110. So how many times percentage-wise, how many times larger is the actual tank compared to the model then? Well, if it was 100%, it would be the same size. but it's 110 times that size. So that would make it 110%. So like 11,000%. Yes, that big, 11,000% times the model, which would be 110 times, because with decimals, with a percentage, you put a decimal right there, two space over, and that would be a 1. So 110 times the original, or 11,000% bigger if it's 110 times bigger. So, and if you were to take a cross section parallel to the base of the holding tanks, remember cross sections? Let's see, I had some notes on that in my notes. Cross sections. All right, we talked about cross sections, so I made this note page for the test. So I would have this like a sphere. Like if a sphere, if I take a cross section, doesn't matter what direction I take it, I end up with a circle. With a cone, it depends. I can have a circle if I go parallel to the base. I can have like an ellipse or an oval, an ellipse. If I do it at a slant, I can have a triangle if I do straight up and down through the top of the cone. So for a cylinder, said if we have a cross section parallel to the base of one of the holding tanks, the holding tanks are a cylinder, how would you describe the shape? What shape is that from the base if we take a cross section of that parallel to the base? Now think about that. I told you where the base is. The base doesn't change just because it's lying down. The base is the base is the base. So a cross section of the base of one of the tanks. Think about that too. One of the tanks. So that is the assignment this week. That's what we're working on. Whale World. The Whale World. So if you have questions on that, let me know. But that is just a basic overview of it. That's what you'll need to do this week. So that's all I'm really needing to go over this week. So if you have a grade that's higher than 70%, you are free to leave if you like. If you're below 70%, you need to hang out in class. You need to have a Buzz tab open. You need to be working on something to get your grade up. If you're behind on assignment, work on something you're behind on. If you're caught up on all the assignments, you can work on this week's assignment, or you can go back and retake something with a low grade. But one way or another, be working on something during class if you need to be here. So the recording will be on Google Classroom. I will also add it in Buzz, so you can go back and look at this later. If you're not going to work on this assignment now, but you don't want to forget this, I will have the recording available, so you can go back and review it at a later time.